All right, welcome back, everyone. We're going to go ahead and get started with our session on net zero and embodied carbon design funded by the DOEE Innovation Grant with our team from Quinn Evans, if y'all want to pop back on here with me. We have Director of Sustainability, Julia Seipel, and Associate Nikita Reed. Ladies, go ahead and take it away.
Thanks so much, Katie.
Great, and give us 1 second. Let me make sure sharing screen. All right, are you seeing it?
Yep.
Yep, looks great.
All right.
Looks like we're good to go. So thanks for having us here today, and thanks for making time to join us. We're going to walk you through a couple projects today where we had the opportunity to use some grant money available through the DOEE. So just a tiny bit about ourselves. I'm the Director of Sustainability at Quinn Evans. I'm a Senior Associate based in our DC office. And Quinn Evans is also in Baltimore, Richmond, and Michigan, and Detroit and Ann Arbor.
Yeah, and I'm Nikita Reed, and I'm an associate out of our Baltimore office.
So next slide. You get, of course, by doing all these Code-paloozas, lots of learning your AIA credits. So you'll get those for this one too. So we won't go through those in depth here, but credit and HSW credit, of course, which is great. So I'll give you just a bit of context about the DOEE grant, and then we'll talk about our projects. So Quinn Evans submitted for this grant actually about 1 year and 2 months ago, and was awarded the grant now about 1 year ago. We did the work primarily over last summer. So we're going to share some information about our grant projects, as well as what this grant is all about. It's kind of cool that the city and DOEE makes these funds available. So this is really an opportunity to get some additional design assistance funding. So for the design team early in projects to really think about how we can go further when it comes to high performance design. So this is kind of taken from the DOEE website directly from the way that they've worded the grant language this year. The objectives of this grant, which is called the Green Building Innovation Assistance Grant, is to reduce the environmental impacts of the built environment in DC. And then it's how to really build capacity and share that knowledge, and how we're doing those things, how we're designing high performance buildings. So really the outcome being really clear case studies that then can be shared out. And so this is one way we hope to kind of share the outcomes of some of that work today with you guys. And we'll include a link to where this is at the end of the presentation, but feel free, the best way to find this really is frankly to Google DOEE Green Building Innovation Assistance for more information about the grant. Next slide. And so, really what the grant is asking for is to look at a few different categories and approaches for high performance design. I believe this is the 4th year DOEE now has offered the grant, 4th meaning this current year where this was opened for applications earlier in this year, and they're reviewing current applications for award for the summer. I'm showing the latest of this grant funding application, but it was a little bit different for the year that we applied for this, which was the year prior. And it was different from the year prior to that. So I think what's also interesting in this is the evolution of DC thinking about how they support and encourage high performance design and really help the designers think about how to showcase that work and kind of advance that work. These were the 5 approaches outlined for this current year: net zero energy, building electrification, renewable energy storage, embodied carbon, deconstruction and reuse, and this kind of suggested funding pool that you could apply for. What's great to see is these funding amounts are even bigger than when we applied for this the year before. So we applied in the net zero energy category and in the embodied carbon category for 2 separate projects. So those are the projects that we're going to share a little bit more about today in our presentation, just to share a little bit about how we made use of this money and how this is something that is really great to be able to have that extra injection for our design teams, so that this is something that we don't have to absorb some of these costs, and how we're learning this and pushing this that much further on our projects. And it's great to see this expand both in the costs and also in those categories. So when we applied, it was just the two categories, net zero energy and embodied carbon. And so those are the two categories that we pursued. So it's cool to see that expanding. Want to also plug here, this is another resource that Nikita probably will mention a little bit further when she talks about the project she was involved with. This is the Net Zero Energy Project Guide. So there's other resources that DC has made available that really help to promote high performance design. So just wanted to make a plug for this one as well. So mostly wanted to then talk through and move into our two project case studies today to share kind of what we got out of using that design assistance money. So first is, I'm going to talk about this project, which is the Southeast DC Neighborhood Library. And then Nikita is going to talk about another project that we're working on, which is Hyacinth Way, also in DC, is a multifamily project. What's kind of interesting about the timing of this funding available is it's fairly, these projects kind of move slowly sometimes, but you have to kind of catch that right moment of getting the right study at the right time for a project. I think everyone's probably familiar with that feeling of like, it's too early. Oh, we missed the boat on doing this study, and that would have been helpful earlier. So a trick is to really think about in the lead up to that grant submission process, what is going to be helpful in terms of the timing of the project and where that can fit well with either something you currently have or that's kind of coming up in the works. So we didn't actually apply for the grant this year. This is the two grants that we won the year prior. So for 2021, those grant funds, and these are projects from the prior grant cycle. So for us, we just hadn't have a right fit of a project this year and really wanted to kind of double down on some of the things that we learned from the grant last year. So this is the project that we focus on embodied carbon. And so I just wanted to kind of share, this is a really cool project, and just wanted to share a tiny bit about the project and a tiny bit more about what that looked like in terms of what we were able to do by applying those embodied carbon grant assistance funds to kind of take that further for this project in particular. So next slide. So this is a DC Public Library project. Quinn Evans is the architect, Silman is the engineer. That was, doing this grant. Definitely we involved Silman. Chris Bird from Silman was great in terms of their knowledge of embodied carbon and helping us to kind of work together to figure out how we do these calculations and what are the strategies that we should really look at. This is also a project with Whiting Turner, and I'll talk about Whiting Turner a little bit too, and some of those conversations that were really helpful in terms of exploring what the concrete suppliers were able to provide for low carbon concrete options. Next slide. So, and go ahead, next slide. So just a tiny bit of context here about this project. We are currently in design development. We're kind of just starting that process. It's a project that's been kind of slow to evolve, a lot of neighborhood engagement, historic building, so a lot of review process. It's right across the street from the Eastern Market Metro. It is kind of this kind of two-story and basement existing building. It was a 1922, one of those original Carnegie libraries. So just a very cool location and a great opportunity for us to think about, okay, what are the variety of different sustainability stories that we want to do for this project? But in particular, how do we value the carbon of what is already there? And then look at strategies, well, okay, how do we take that further? What can we do to go beyond the building reuse and to think about the strategies for even lowering that much further on the project? So it's an existing building and a lot of constraints on what we can do for that envelope. So you'll see it looks largely similar to what it does today, though we're adding that new entrance that is accessible and trying to figure out strategies for adding daylight. So if you go to the next slide, you'll see a huge portion of what is being done to this project is figuring out how we add some space, but with the constraints of the historic aspects of the project and the really tight site, it meant that space was down. So getting good daylight into that space was definitely one of the challenges, and other things that we're looking at from the standpoint of sustainability and health and quality of this project is a lot of the quality of those daylight spaces below grade and getting that light from above. So that's kind of the gist of what is happening to this project. It's a major renovation of it, but also a huge expansion of this below grade structure. Next slide. So what that meant then for kind of narrowing in on the embodied carbon piece of things is we wanted to really better understand the research, like particularly our materials in concrete and steel that we're going to be doing this significant below grade structural work. What can we do to make that any better? What can we do to emphasize the value of reuse, but also what can we do in improving those material selections? We wanted to think about fine-tuning our methodology. How are we approaching this? How are we benchmarking what it would have been like, the comparison of reusing the existing building to demolishing and building new, and then adding on to that our strategies for further additional low carbon materials. So doing that methodology, doing that analysis with some kind of low carbon analysis, and then thinking about, okay, what are the recommendations? What can we take away for both this project for us and also hopefully for other projects and future work that we're working on? Next slide. So just wanted to kind of give you both a tiny bit of context around this, like why we looked particularly at embodied carbon. This might be a little bit of a review for some folks, but this will be like the 2-minute version of why embodied carbon and why existing buildings. And then we'll talk a little bit just quickly about like what we actually looked at for this project and our methodology and our takeaways. So embodied carbon is increasingly something that we're aware of as needing to be considered as part of this kind of whole building carbon assessment. So building operations are a major piece, and the energy used to operate our buildings are definitely a major contributor to global carbon. But what's going into the buildings and how they're getting constructed is significant. It's 11% of the total global carbon emissions. And so I think basically the industry and a variety of different legislation and strategies are really starting to take focus on that piece of the pie and saying, let's not ignore this piece as we continue to make great progress to reduce energy. Let's also make great progress on the embodied carbon piece as well. Next slide. So just, quickly, the difference between operational carbon and embodied carbon, all of this is related to what are the emissions that are associated with building the building, running the building, deconstructing the building. So embodied carbon is everything that is going into the building, all the materials, all the movement of materials, and anything that is involved with replacing those materials. The operational carbon is all of the things that it takes to run the building. So everything associated with the energy. So how is that energy created? Is that renewable energy, or is that coming from fossil fuels, that type of thing? So traditionally, operational carbon has really been the focus because it is a really big piece of that pie. And this project is actually doing a lot of things to make great strides there too, really reducing the EUI. It's going to be all electric. So there's other things that we are doing to focus on that operational piece, but I think this was an opportunity for us to learn a little bit and really bring some calculations to the embodied carbon side of things. Next slide. And then in particular, the difference between new buildings and existing buildings. Operational carbon is really great to focus on when we're talking about creating new buildings, and from scratch, that's one of the most impactful things you can do, is to really make an energy efficient building. But we have so many existing buildings. So it's this balance of making sure to be improving their energy performance. And I think there's a lot of things going on in DC that are kind of starting to really push that as a priority in BEPS and the conversations around BEPS, really emphasizing the need to address building operations in existing buildings. But this is a lot. There's a lot of existing buildings there, and that is a lot of carbon that has already been invested. So I think a piece of this for us too is to say, this is a resource that has already been invested. How do we value that, and ideally continue to drive down operational carbon without having to make a brand new investment of a huge amount of carbon for that demo and rebuild in some situations. Next slide. And I think this is, again, to the same point of like, where is embodied carbon compared to operational carbon over time? And this is numbers put together by the 2030 Architecture 2030, where basically the projections are that we are getting to a place where our operational carbon is really starting to come down by, better codes, more renewables, less kind of dirty sources of energy. It means that this embodied carbon piece is really significant. So how we can address that and be more able to kind of harness strategies to reduce it in new construction, but also strategies to better value it in existing buildings and save existing buildings, is definitely the opportunity that we were trying to learn more about with the embodied carbon component. Next slide. And so then we'll get more into concrete too, because concrete ended up being a big part of our focus for this project. We were looking at steel and concrete, but pretty quickly, I think we zoomed in on concrete being the real potential for reduction. There are a lot of things that you can do across the ways that you can specify the concrete that make a pretty darn big impact in reducing the emissions, the carbon emissions associated with it. And concrete's a big problem, that we use a hell of a lot of it. And it's a pretty darn carbon intensive material. So I think it's great for certain projects where we can really move away from using concrete and use lower carbon materials to begin with, things like timber, but concrete is really useful too. So I think there's so many situations where just trying to find ways for us to continue to be aware of the strategies to reduce the carbon in the concrete that we are using. It's a very durable material. It's a very flexible and useful material. It's hard to get away from concrete. So we're not getting away from concrete, but we'd love to, what are these significant reductions in global warming potential in carbon by some of these strategies of particularly addressing that cement content. Next slide. So this is actually from another project that we were looking at, where we were looking at the different categories of building materials and quantifying the overall amount of embodied carbon, both as a base quantity and then the potential savings looking at typical EPDs. These are categories that actually there's a LEED pilot credit that is associated with this. So this is something we were doing for one of those LEED pilot credits on a project. But I think the reason I really wanted to share that here is how significant the concrete is in terms of overall carbon. And so this will look different on different projects. Your kind of mix of the global warming potential will kind of pan out differently depending on the materials that you're using. But if you're using concrete and a lot of concrete, there's going to be a huge opportunity to reduce the carbon associated with that. So that's that's, we wanted to share that slide there. I thought that was pretty stark. And so I think this is, well, actually can probably skip through this slide pretty quick. This is just focusing again where in the process that carbon is really associated, and the hope being to think about what do we get to control? What can we do as designers and designers working with our structural engineers? Where are the opportunities for us to change the design mix of that concrete, or the flexibility of, you know, of that mix, so that we can reduce the carbon in that step of the creation of the cement in that process. So for our grant, kind of stepping back, we wanted to look at 3 different strategies to reduce embodied carbon. We wanted to quantify the value of reusing and renovating our existing building. We wanted to think about designing with less. So from the standpoint of that below grade structure, we worked with someone to think about kind of 2 different ways we might be able to do that design of that structure below grade. And with that kind of quantity of steel and concrete, that shift kind of be able to amount to something that would be a useful savings. And then last, we wanted to look at smarter specifications. First, we were kind of looking between steel and concrete, and pretty quickly we just mostly focused on concrete, looking at ways that we could specify low carbon concrete material. So for our reuse strategy, you know, part of the reason that this is really important is, you know, the structure of the building accounts for so much of what is the embodied carbon that is already there. You know, not surprisingly, like that's all of our existing concrete, steel, kind of those heavy components. You know, mass is really one of those things that helps kind of indicate oftentimes where that carbon is located in a building. So reusing just the structure of a building is a very effective strategy of reducing the embodied carbon of a building. We are early enough in this project that we have not gotten to a really clear idea of the interior finishes and those other items, but we kind of wanted to focus on some of those big bucket items to figure out if we could better quantify it for this project in particular. So reuse, then strategy 2 on the next slide, design with less. So this is where, for this project in particular, we looked at the different amounts of cement and steel, or concrete and steel in our basement structure. We'll kind of get into the difference of those 2. But obviously there's other ways that with more substantial changes in the design, for example, if we were able to look at timber, it would have had an even bigger impact for the strategy. Our strategies were kind of similar, you know, it was slightly different structural systems with that looked at less, you know, less of one type of material or different sizings of members, but kind of still within that same material family. And then our third strategy was the smarter specification piece. And really looking there at how much of our cementitious material, supplementary cementitious material, could we replace? And then also, can we get away from giving a very prescriptive mix in the concrete and have something that is more of a performance-based spec? And so again, this is early in the project for us. So I think most of this is coming out with strategies for our spec that moving forward, and kind of knowing what is feasible without adding any costs, because there are things that we can do to go even more aggressively. And I think a piece of this is just like how much the market is familiar with some of these strategies. Some of this gets baked in pretty quickly in terms of you know, things like fly ash. So I think it's trying to figure out how we bring that to light and quantify it. That was the big piece of this for this project. Next slide. And EPDs, we had some good conversations on what was available for EPDs related to concrete mixes. The National Ready Mix Institute has some great resources. EC3 has some great resources. It's a little bit tricky sometimes with concrete because it's kind of this recipe of different components. So finding EPDs can sometimes be challenging. But I think the idea being we want transparency and we want to be able to measure. So how is the industry moving towards either having EPDs, which is the best way because it's the most transparent, it's a clear process, versus coming up with, there are other ways to calculate what a mixed design would be for its GWP values. Next slide. And so then lastly, the things that we were looking at, we did, as part of this process, met with Whiting, Turner, and Schuster Concrete. I think in general, this was a great opportunity, and we've been able to now do this on some of our other projects, is those conversations between your engineer and your contractor and any of their subcontractors for concrete suppliers. It's really interesting to see the variety of where people are familiar with us in the industry right now, and it varies a lot. And so even those that are not familiar know it's coming. So I think there was a lot of interest even with some of the people that kind of knew less about how to do some of those calculations. So it was a very helpful conversation, and I think we got a lot of support from kind of everybody there at the table in interest of kind of understanding what this would mean for the project and where we could have any flexibility to improve the GWP without adding costs to the project. So this is where we kind of got to our cementitious material. 35% is kind of where our project is sitting in terms of the replacement value for the cementitious material. So, lastly, I just kind of quickly want to share what we learned and did as a methodology here and our takeaways for this project. We used, this is an interesting thing when you're trying to benchmark, how much did you save by not demolishing and building new? Clearly, this is an existing historic building. We really weren't going to ever consider tearing it down. But how do we value that and value that from a carbon perspective? So I think there's different ways to do this. And what we tried to do is to assume what it would take to demolish that kind of above grade component and rebuild it with something similar in modern materials and methods. So it's not trying to say to rebuild exactly what is there, but basically a similar volume, similar purpose rebuild. And so we were using primarily for that the FINA Sustainable Materials Institute tool, which helps kind of, a lot of this is about capturing the right tool for the level of detail that you're interested in seeing. Next slide. And then the second part of that was, okay, well, what are we adding? What is the new stuff going into this building and with our below grade expansion? And so this is where we worked a lot with Silman on how to come up with the quantities, and then what are the carbon quantities that we should use for those material takeoffs. So we looked at EPDs for different materials that we were using in the concrete and the steel to come up with the quantity of carbon there below grade. Next slide. So, we looked at a few different, this is the summary of our different options here. And this is looking at 2 different design options. So like 2 different structural options for each of these strategies that also then look at varying degrees of the % of replacement of the supplementary cementitious material. So if you go to the next slide, I'll just kind of jump to our conclusions here. Clearly the demo and rebuilding added a substantial piece of carbon of that rebuild that all of our other options were able to avoid. But none of our design options where we kind of changed the configuration of the structure to kind of tweak the amount of concrete had much of a difference. It had a minor difference. So it was really that ability to, the more of the concrete cementitious material we were able to take out, the better, substantially better the overall embodied carbon of this project, just because there's so much concrete and significant structure below grade that were really involved with the design of this addition. So next slide. This is kind of just a different way to see this in a quick summary. Here is our opportunity of the savings of reusing the existing building and designing our concrete spec to be low carbon concrete. Has very kind of significant carbon saving opportunities that we were definitely looking to make sure we reflect as part of the opportunity to value that reuse strategy, but also really important to continue to make sure these are things that we can get into our specifications. Next slide. And so then this is my last slide, and then I'm going to turn it over to Nikita just to share a little bit of some of the examples from our net zero project, which are really cool and exciting too. But we just wanted, how did this help Quinn Evans too? Not just this project, but how has looking at embodied carbon really helped us to get that process clearer? We do a lot of work with existing buildings. It's really nice to be able to go that step to be able to better quantify the value of saving the existing building. Of course, it's hard to come up with a good strategy to value savings of what is already there. And so I think making sure that we can continue to think about how that's included in the process is really something that we think is important in that total carbon story. And that conversation with the engineer and the contractor, that was super valuable stuff that we've been able to do again. The things that we can talk about, the questions that we can ask, strategies that we might be able to look at together or offer. We definitely have a clear playbook of what those things can be. So, and particularly for concrete, I think that's something now in projects of a variety of different scales, we've been able to do low carbon concrete specs now on projects that are very small and projects that are really giant. So ways that we're seeing how that works at projects of all scales and doing that more often. Because I think, again, it's just needing to make this more commonplace and easier to get the data about what is actually going into those concrete mixes. So I'm going to hand it off to you then, Nikita.
Awesome. Thank you so much, Julia. And so one of the things that I love about that project that Julia just shared is that it really does show the different thoughts that went into how can we actually think about embodied carbon within existing buildings. And so we're going to pivot though, and we're going to talk about new construction. And so as Julia mentioned, this is the project that we went after for the grant to explore some more net zero options. And so with this project, the grant goals were to explore architectural facade options to get a better sense of how different designs would impact the use of the energy use of the building. We also wanted to conduct more iterative energy models. We'd already had the energy modeler on and did about 3 energy models before we got to the grant. And so the grant enabled us to really study a lot more things through different energy models. And then also do a little bit more in depth of what renewable energy would make more sense on the site. So the grant really helped us explore those 3 areas a little bit more. Our grant project team consisted of us as well as New Ecology to do the sustainability and energy modeling consulting. And then on the full design project team, we're also working with SETI engineers or SETI and associates for mechanical, electrical, and plumbing, as well as Linton Engineering for structural engineering. And so I'm going to get into the project and give you some more of the constraints and what we're working with. The project, when we started the grant, we'd already gotten through mostly schematic design, but we're still very early stages right now of design development. And the site is very constrained. So it is located in Southeast DC, and it's in between Bruce Place and Stanton Road, and it's very narrow. And there's about a 50-foot drop from the top of the site to the bottom of the site. So we're working with a narrow site with a very steep slope, and the demographic is to serve formerly homeless seniors. So the client on this one is the Institute for Urban Living. And it's really important for the client and for us as designers to make sure that we are increasing the energy performance and then making the building as comfortable and affordable for the residents as possible. So it's going to end up being new construction, about 70 units. And so we ended up breaking the building into two different pieces, one to accommodate the narrowness of the site, to also then create some different meeting places and gathering spaces for the residents to be able to have outside space that's still contained within the building. Since this is going to be a building for formerly homeless seniors, and some of them would have mental health diagnoses, we wanted to make sure that there would be outdoor space that could still be secured and contained. And so at this point, we are assuming that if you're on this call, you are totally bought into the net zero concept and why it matters, and the fact that we're really trying to make sure we are designing buildings that are producing as much energy as they consume over the course of the year. Julia explained the stats in terms of operational and embodied carbon, and then also just from a net zero standpoint, really paying attention to what our buildings are producing and how they're impacting climate action. And so throughout this grant, we were looking to optimize systems and reduce loads. A lot of times designers try to only, they don't do the right things in the right order. So we were trying to make sure that we were doing the right things in the right order by optimizing and reducing, then exploring passive strategies, and then looking to utilize renewables. You don't just want to slap solar panels on a building that is not optimized or using passive strategies, because you're going to end up not having the same kind of gain as you would if you actually did things in the right order. And so we made sure that we decided to select design strategies to test via the energy model. Sometimes designers that we've talked to try to wait for the energy model to tell them what to design, what to test, but it actually needs to flip the other way. So as the designer, you have to decide what are the different things that you want to test through the energy model. And so we were looking at what could we do with sun shading, what could we do with the window to wall ratio, as well as what could we do to change insulation around the building. So looking at slab insulation, wall insulation, and roof insulation, and how all of those would impact the site EUI. And then we then looked at, okay, well, how do we then perform the energy models to test these assumptions that we're making? And so the energy modeler looked at the roof as well as the window to wall ratio, and then the full building site EUI to see what would happen as the different variables were changing. We then looked at exploring the renewable energy options. And so we looked at wind, geothermal and biomass, solar, photovoltaic, as well as fuel cells. We did not look at solar thermal for this building, mainly because of the use type and the systems that were selected. But then the graph at the bottom is showing how we were testing the assumptions of how the EUI, or the energy use intensity, would be reduced based on the different steps within the process. So starting with the baseline, what would happen after we incorporated the energy conservation measures, then what happens once you incorporate renewable energy, and then what would have to be offset to get actually to net zero. And then we analyzed the results, and we had to keep reminding ourselves that energy was only part of the equation. And we had to also consider occupant comfort and affordability to figure out the ways to move the project forward. And some of the challenges and limitations that we came into were that since we were running so many different iterations, we had to be mindful to minimize the variables so we could really compare apples to apples as we were going from one situation to another. And then, as you'll see in some of the coming slides, the energy reduction number didn't move as much as we thought it would in some of the instances. So we had to remember to keep looking at the numbers holistically and taking into account the energy reduction measure compared to the cost savings compared to the site EUI. And so let's get right into the design parts of it. So in terms of the building facade design options, there were 3 that we were looking at. The first one was what would happen if we had a low window to wall ratio. And so for this one, we kept the window to wall ratio right around 15%. And that way we could take advantage of thermal advantages of walls over glazing. In this section, you can also see how we were mitigating the slope of the site. So you would enter the ground floor at the higher side at Bruce Place, and then the garage is actually 2 floors lower just because of the natural slope of the site. So then the next one we looked at was what if we increase the window to wall ratio? And so this one we increased it up to about 20%. And we also modeled what it would be if we had double pane windows versus triple pane glazing, and looking at the different solar heat gain coefficients. And then the third option was what would happen if we actually put sun shading all along the south side, just to really get a sense of how things how the energy model would react to those options. And so getting into the numbers, we kept the baseline was ASHRAE 90.1 2013, just to establish the baseline for all of the models that we were going to run forward. And actually, the system that we chose was the Chiltrix heat pump system, which is an air to water heat pump. And that one actually found to be the most energy efficient based on various energy models that we completed early on. And so that was the baseline for all of the different energy measures going forward, just to caveat that. All right, so under the slab, we were looking at what would happen if we insulated under the slab. So either with one being no continuous insulation under the slab, another being R10, another one being R20. And so at first glance, when we're looking at the site EUI, we saw a little bit of variation between if we had R20 at the top versus no insulation in the middle versus R10 at the bottom. But there really didn't seem to be that much of a variation. But then when we're looking at the actual reduction at the bottom from the energy model, you can see that the first one, and I don't know if you can see my mouse, you may not be able to, but so this one being the baseline and then comparing it to the R20 under slab. And there is actually a significant difference going from, negative 5.8 to negative 1.8. And so looking at how the numbers changed per ECM helped us get a better sense of, okay, well, what's happening with that one measure, even if there's not a significant change happening overall to the site EUI. And then this is just more numbers kind of as we were looking at it. And so the baseline stayed the same, but then there were still numbers that were being crunched throughout all of them. So just wanted to show the numbers. The next one we looked at was in what happens with the wall and if we change the insulation. So what if we go with 2x6s with either 1.5 inches of continuous versus 3 inches of continuous insulation, or if we update it to 2x8s, and what does that look like? And so it was interesting also to see that there really wasn't that much of a change on the overall site EUI, which would then impact the annual energy cost. But that just gave us a sense of, okay, we have a little bit more flexibility with the design options than we thought we would. And then moving on to windows, this is where there was a little bit more variation. And so looking at both the double pane versus triple pane at the various window to wall ratios, as well as what happens when we add shading to either a double pane or triple pane window, and how does that vary? So on the top chart, you can see that if we're doing a double pane at 17% window to wall ratio, the site EUI is about 27.24. If we do triple pane, then it decreases a little bit, but then it decreases even more as we add more shading or we go triple pane with shading. So some of this was verifying the things that we'd learned in school, and we've always thought triple pane being more energy efficient than double pane and all of that, but then really seeing the annual energy cost savings on an overall site EUI, we realized that it may not move the needle as much if we're only looking at one particular thing. So this is where we, again, had to keep thinking holistically about the project. And then we looked at the roof. And so this is the one that surprised us the most, because this is all energy model looking at the site EUI and cost savings over assuming that we're putting continuous insulation above the roof deck. And as you can see, the site EUI stayed basically the same. And that did not make sense to us because, you know, if we're doing more insulation at the roof level, what's happening there? And so then thinking through it a little bit more, and then also looking at what's actually happening to the reduction, you do see that there is actually a percent change between baseline, depending upon the type of insulation and the thickness of insulation that happens above the deck. But because the roof insulation would be above the deck in this instance, and it's a housing project where there's not going to be that many shifts in temporal change, that's retired seniors who are going to be home most of the time, and the roof is really going to be impacting more so just the top floor. There were things that started to come into play where we realized that there really was going to be a payoff after a certain level, depending upon how much insulation we put on the roof. So it was good to be able to keep things in mind, because more isn't always better. There will be some diminishing effects after a certain amount of time or thickness of insulation. And so then we jumped right into renewable energy analysis, and we were very grateful because we had a client who had a desire to have no fossil fuels on site whatsoever. And so that's something that we are still working through with DC, because even in terms of having a diesel generator, the client is pushing back against that a little bit. And so there's some code and permitting questions and issues we have to still work through on this project. But all that being said, we did want to look at what are the different renewable energy options that would be available for this particular project, knowing the site and the project type and the constraints that are here. And so our proposal, or our final presentation, is actually online, that Julia mentioned, but this is just a snapshot of the different renewable energy analysis. And ultimately, it was determined that solar would be the best candidate for a renewable energy on the site. Micro wind turbine, geothermal, biomass, all of those things didn't quite work, unfortunately, on the site. So then we also looked at the fact that there's just a number of different elements that we had to keep in mind for the project to make sure that we are selecting different energy conservation measures and really getting this building to be as net zero or close to net zero as possible, so that we would be able to still get there even with carbon offsets. And then I just wanted to wrap up with the fact that energy modeling really only tells part of the performance. And sometimes you have to be mindful of the different indoor environmental air quality measures, such as higher ventilation rates, which really support resident health and comfort. But there's also an energy cost to that. So being mindful that we're balancing energy usage versus energy costs versus comfort of the residents, and how that all plays together. And then ultimately, also training is going to be a big part of making sure the building stays operating in a net zero manner. And so for this particular project, the grant helped us really explore additional energy iterations. And also it'll impact the way that Quinn Evans designs projects in the futures, now that we actually have a better understanding of more of the numbers and how things work based on the different parameters that we were able to run. We have about 10 minutes for questions. And so we wanted to go ahead and leave up some resources for you to look into. And then also feel free to reach out to us if you have any questions. And so with that, I guess, Katie, I'll invite you back on. Do you want to run the Q&A, or do you want to stay here? Oh, perfect. Okay.
Yep. So we have a few questions coming in already. For the first project you discussed, how did the design team go about engaging a general contractor and concrete supplier so early in the project?
Yeah, I mean, it really depends on your the structure of the project. This one, we were lucky; it's a design build project with Whiting Turner on board, and Whiting Turner has been really great in terms of trying to help advance the sustainable strategies. So Terry Bosnick is who we're particularly coordinating with at Whiting Turner there, and she was great and brought in Schuster, who they often work with. So I think that is where just having the relationships for that particular project just really helped drive that conversation early, which was great.
Great, thank you. In your opinion, what is the future of the concrete industry, and how they can make long-term changes and improvements to concrete mixes and development to reduce embodied energy?
That's a great question. So I think there's a few things probably, and you know, hopefully there's continues to be more and more new innovations. I think to some extent, it's like, how do we continue to use less concrete is one of the things. But then with concrete itself, it's just such a versatile material. I think continuing to find other materials that we can use instead of cement is a huge part of it. You know, our availability of things like fly ash changes for, you know, that's a good thing that we don't have as much fly ash available. So like those coal plants aren't burning quite as much, but finding other things that are getting into these mixes in affordable ways. I think that affordability piece of it is really key, and making it a market standard rather than something that we have to choose to be putting into our specs. And so I guess along that lines, it's, you know, how do we make sure that the GWP value, you know, that global warming potential value is actually a piece of every concrete submission data that is required for a project? That would be great if it even had to just be calculated and provided for every single project. I think we're missing a lot of data about what is a reasonable benchmark. The National Concrete Ready Mix Association has a lot of kind of relatively new data around this that's really helpful, and that's what's driving kind of the floor, like what we're comparing our savings to. But I think it's really important that we continue to require those numbers to be provided on all of our concrete submissions, and find more mechanisms to require that, because that is really what will let us then push for greater improvements on that too. We didn't talk at all about carbon capture and entrainment techniques, so things like carbon cure. So there's ways to inject carbon actually into the concrete, which even it actually improves the performance of the concrete. You know, there's the cost balance of that. How do we make all of these things that much more part of the standard process and affordable? That's a piece of it, but there's opportunity for concrete to actually be capturing carbon, and to get it to be a pretty darn low carbon material, as opposed to this like highly carbon material. So, you know, it's pretty interesting, those opportunities, and where the market really needs and can help push that.
Thanks. Oops, sorry, my Q&A box just closed. So energy modeling team, one of our participants is saying that their biggest challenge is getting the window to wall ratio for multifamily below 40%. So
Yep.
for the Hyacinth Way project, did you start at 15 to 20%?
We did, and mainly because we knew we were going to be going for net zero early on. And so our consultant recommended that we stay in that range. And so that did help. It also helps that for this particular client, it's affordable housing. And it's also formerly homeless seniors who have a mental health diagnosis. So there was also a desire not to have balconies and other things that could present jump risks. So there were a couple constraints that were working in our favor in terms of keeping the window to wall ratio low. It wasn't kind of the typical new construction market rate where they want floor to ceiling windows and all that. So there were some advantages that we did have for this particular project type and client.
Great, thanks, Nikita. What software were you using for your energy modeling?
Oh yeah, and so the energy modelers were using eQuest, and so they were reminding us that eQuest, it's an imperfect, blunt tool that helps kind of give the big picture. It's not the precision scalpel that some of the other energy models may provide, but because of where we were in the project, that was the tool that they recommended most for it.
Okay, thank you. And we have one last question. I think you touched on this in the beginning, and this information might be in this link that's on the screen right now. But is the funding only for district-owned buildings or for any building within the district? And where can you find more information about the funding requirements?
Yeah, no, great. So the DOEE grant is called the Green Building Innovation Assistance Grant. Best way to get there is frankly to Google that. That is that link right there, but I recognize you probably can't click on that in this. Probably drop that into the chat. But just if you Google that, it should come up really readily. And it is available to any project in DC. It does not need to be publicly owned. They do prefer if the client is at least on board and supportive of the project. So, you know, that's one of the things that's included in the application if possible, but not a requirement. And so it is often the design team that is submitting for these grants, which is what happened in our case. We submitted for 2 grants for the 2 different projects, so that we were able to get awarded kind of 2 different approaches in that same year. So it is open, let's see, this year I think it was open till February, it was the submission timeline, and it's September 30th, I believe, is when all the grants wrap up, because basically they're working in their fiscal year budget. So hopefully things continue to go the way that they have. I think this is the 4th year that they've now done this grant, and it continues to expand. So hopefully we continue to see that trend for money available to support high performance building. But it's great that, you know, so far DOEE has offered this grant that comes out kind of end of the calendar year or early in the following calendar year. When you submit for it, then they award it sometime around now is when they'll be awarding, or very soon, I'm sure, awarding the grants for this year, which will be pretty short then, you know, that has to wrap up by September 30th. And so then hopefully they'll be doing that again next year.
Yep. And so the project that we did, the building, or the land rather, it's not actually a building yet, was owned by a nonprofit. So it's definitely not just for DC owned buildings. And I'm going to put in the chat, sorry, a link to where all of the previous grant funding, or the grant information, as well as where the full proposals or final reports lived from last year. So our reports are on there.
Yeah, and we were the grant applicant. I see the next question here about, does it get issued to the owner or to the design firm directly? And so it really depends on who submits for the grant, and that is the relationship then that is established with DC, and you can have sub consultants under the grant. So for us, the grant money came directly to Quinn Evans, and then both of our teams also shared a bit of our grant money with our sub-consultants. So for the Embodied Carbon, that was Silman, and for Hyacinth Way, that was the energy modeler on that project. You know, it was a great way, frankly, to advance some of the initiatives that we hope to do more of on our projects, and to help projects that are currently in process go just a little bit further and develop some graphics and some things that really help better explain that and tell that story too.
Mm-hmm. Yeah, and one of the things that I really appreciated throughout the process was that we had monthly meetings with DOEE as well. That's part of their grant requirements, and it was great to really be able to track through the process. Hey, this is what we're looking at, this is where we are, this is what we're thinking of. So really getting feedback from the staff there as well. So they were really great to work with. Yeah, and I think they were really receptive too in terms of the things that worked well, and things that, any suggestions we had for the following year. And so I think we saw some of those suggestions incorporated into the latest version of the grant language this year, which is pretty cool. So it's definitely a great resource that I think is available for some funding for design, and how we can advance our design for high performance buildings in DC.
All right, well, thank you both so much. That was the end of our questions. I have one more sponsor